In this demo, we'd like to implement a remote procedure call framework from scratch. Basically, we'll have a concurrent TCP server which will allow us to consume services remotely. First thing that we need to do is to define how the request and response would look like. So we'll have a RPC request class, and when we call a service, we specify the name of the service, the name of the method, an argument array which we'll use to call the method, and we support publishing as a singleton but also as a session. So first time when the consumer is invoking a service remotely, the runtime on the server will create an instance for that service to call a method in case the method is not static, and it will return the session ID, which will be later used by the client to say to the server, hey, the next calls should be executed by this instance that was previously created. So we specify the name of the service, method, arguments, and session, and we only have getters to return those values. We'll have a special method, let's call it destroy, that's going to be used to delete a service instance on the server side. Now, the response should contain either the result of executing the method on the server or a string in case we got an exception. When we create an instance of the service type on the server side, we will return the ID of the session for that instance to the sender, to the caller, to the client. So we have getters and setters for those fields as well. Now, having this created, we have to implement a concurrent TCP server. So on the server side, we have a TCP server which actually have several methods. First of all, when we create a server, the server will hold a map of services. So we will publish a service identified by a name, and we'll have an RPC service wrapper which will handle the execution of the service methods. Each time we publish a service by a name, we can publish a type, or we can publish an instance of that service. So all we have to do is to put in the map of services by the key which represents the name of the service, an RPC service created either using the type or the instance. Of course, we will have an utility method to unpublish a service by the alias, by the name of the service. And then with this, as you can imagine, we have in the server class, we have this map. Now, when we start the service, to listen on a particular DNS or IP of the server machine and on a given port. We first stop the service and then we create an executor service. So we have a thread pool with a pre-allocated number of threads, which depends on how many cores the processor has on the server machine. Let's say that we create 10 times more available threads to execute workers, and then we create a server socket. This is a member of the class, so we have a field for the socket and for the executor service. Now, all we have to do after creating the socket, which is first binding to the IP endpoint and then listen to incoming requests to accept to accept TCP connections, we then submit a worker to the executor service. This is because we'd like to have a thread running in background which will wait for incoming connections to accept TCP connections from the clients. So we just iterate as long as the socket is not null and it is not closed, and what we do, we accept the TCP connection and then we create a worker to listen to that incoming connection. So the worker has to be runnable and it will receive the accepted socket to communicate with the client, and we store the socket as a field in the class. Now, when the worker is going to run, we check first that the socket is not null and it is not closed, and we need to read and write from the socket. So we will read each line at a time, so we create a buffer reader to read the lines, and we just create a print writer to output the result. As you may see, we use the input stream of the socket, then create an input stream reader on top of it, and then a buffered reader to read with the line separator. It's the same, we get the output stream of the socket, and then we create a print writer on that. Now, what we need to do, we need to wait for incoming requests from the client. So we check if the input stream has some available data to be read, and then we have a transport layer to deserialize the line that was read from the socket, and we just say to the transport that we need to deserialize an RPC request. Later on we'll see how this deserialize method works, but in fact we are using JSON, and we are using the Google implementation of the library called JSON. Now, what we do here, we will create a response as a placeholder. If the request is not null, so we were able to deserialize a request, we then check what is the name of the service that is in that the customer wanna call. It is possible that we don't have that service. So first we check that we have a published service with this name. In case we don't have a service, we just set a fault saying to the to the caller that the service is unavailable. Now we take the service, which is going to be an RPC service, our wrapper, from the map, and we ask that to process the result, to process the request and create a response. So after having the response created with all the fields, either with false or with the result of the execution of the method, we then use the transport to serialize this response, and we just print that on the socket and make sure that we flush all the data we send to the stream, and therefore we completely send the response. If we are unable to pass a request, then we will set the fault on the response, and we'll tell to the caller that this was a bad request. Now, this is how the worker proceeds, but let's see what the process method should do. Apart from that, in this class we also have utility methods, not just to start listening for an incoming connections, but also to stop it. So when we stop the server, we check that the socket is not null and it is not closed, and we close it and make it null, so the garbage collector will deallocate it at some point. We do the same with the executor service. If it's not null, then we shut it down and try to free the memory. We also implemented this class as auto-closable, so we should have a close method, which is actually an alias for the stop. Therefore, we will be able to use this RCP server in a try resource statement. Now, let's concentrate on what an RPC service does. So if you go in here, we are calling the process method of an RPC service. We created a class for that. An RPC service is a wrapper that can use either the type of the service or one instance in case of a singleton publishing. When we register a service by a type, we store the type as a field in the class for later use, and we need to create a map of instances. So we use a string ID as a session for the instance, and a reference to the object representing an instance of this type. Now, when we publish a service using only an instance of a service, that means that all the callers will dispatch the call against the same method, the same instance. We store the instance and we take the type of the instance as being the type of the service. Now, all we have to do to process a request, we'll receive the request, sorry for that, we will receive the request and we also receive the response. So first of all, we take the session from the request and we check if the caller is asking us to destroy the instance on the server side. If so, we then check if we have a session for this value, and if we do have a session, we just remove the session and make sure that the session ID is set to null and this value will be sent to the client. Now, if it's a normal method to be invoked, we need to take the target of the invocation, which instance should dispatch on the call. Initially this is null. We then check for the method, which method the clients want to call. If we go here, all we need to try to find, we have the type of the service and we take all the publicly available methods of that service. Then we make a list out of it because we like to filter it as a stream. We take the stream and we apply a filter. So we accept all the methods that has the same name as the method requested by the caller and that has the same amount of parameters. We are not able to support actually method overloading apart from different number of arguments, because when we receive the request we only take an array of objects and we have no idea what is the type of the objects, so we don't know what is the actual type of the arguments. We only know the name of the method and how many arguments we have. So in case we take the first occurrence of this stream and we return an optional of method, because it might be the case that we have no method matching the filter. Now, after searching for the method, if the method is present, that means that we found the method, we need to invoke the method. Otherwise, if the method is not present, then we set a false saying that the method is not allowed. Now, suppose that the method is present. In case it is a static method, we don't need to create an instance. So with a modifier that is an utility class in the reflection API of Java, we check if the modifier of the method is static. If it's not static, and only if it's not static, then we need to create an instance or to trace back an instance. Otherwise the instance should be null, which is already the case. Now, we check if the service was published as a singleton. In this case we use this instance. Otherwise we check if we have a session from the client side and we do contain an instance for that session. If so, we take back the instance from our map. If not, we need to create a session ID, so we use an uniform unique identifier. It's a global unique identifier. We take a random one, which is creating a value based on the IP of the machine and the timestamp, and we take the value of that string. Then we also create an instance by getting the default constructor without arguments of the type and instantiating a new object, calling that constructor. Now, this is what we do up to this point. So we have an instance. Now we need to deserialize the arguments of the method, because we just box we are boxing the arguments as object array, and when we deserialize the request we have no idea what type of objects we need to take from that. There is no information about the type of the objects of the arguments. So now, having the method, we take the method that we try to find and take the type of the parameters. Now we take the arguments from the request, we iterate through the arguments, and we deserialize from each argument, which should be a string up to this point, based on the type of the argument of the method. Now, having prepared the arguments to call the method, we invoke the method using the target instance and these arguments. And this is going to be the result that we return. In case we get an exception, we then set the fault to be the description of the exception, and in the end, we set the session of the response. So this is what the utility RPC servers service is doing. Now, going back to how we consume the service. But before that, let's just see how the transport works. So we are using JSON, and we have a method to deserialize from a string a given type, and we just call the JSON from JSON to take from that string and pass this type of object. And we also have a method to serialize an object. In this case, we use the JSON, and we call the toJSON method to serialize as a string this object. However, if we do so, we will have issues deserializing the objects from the request and from the response. Remember that we have an array of objects for the arguments of the request, and we have an object for the result of the response. Therefore, we have to do some custom serialization. So what we are doing before creating the JSON that we use to serialize and deserialize, we use the JSON builder and we register some type adapters. For instance, for the RPC request, we create a deserializer, and for the response, we also create a deserializer. What those deserializers are doing is the following. When we deserialize a request, we take the object from the element that it was deserialized, and we take the property service as being a string. We do the same with the method and also with the session. As for the arguments should be deserialized as an array of strings. So we iterate through all the items of this array, we take the iterator of the array, and we add the toString representation of each item in the array. So when we deserialize a request, we just keep the initial serialized form for each item in the arguments array. Now, we just create a request with these values. When we deserialize a response, we do the same. We take the response, we create a response, we take the deserialized JSON element, we take the result, and because we don't know what's the type of the result, we keep the result as a string, as it is serialized right now. But then we take the fault and we know there should be a string. We take the session and we take this value out from the session as a string, and we just set this on our response, and then we return the response. Now, how we are supposed to call and consume this? We create a proxy. So the client will just call this with a proxy. So what we are doing now with a proxy, we'd like to be able to implement dynamically a contract at runtime. Therefore, we have a method to create a proxy, and we'll say this is the interface. It should work only on interfaces. So we define an interface that's going to be the contract of our service, and then we know where the service is available at a given endpoint. So we are using the Java reflection support to create a new proxy instance that will generate a class loaded by this class loader, the class loader of the contract of the service, and we will say what interface is to be implemented. So what this new proxy instance will do is going to create a new class at runtime that's going to implement these interfaces, and the class will be loaded on this class loader. The way it's implementing the interfaces is by using an invocation handler. So we create our own invocation handler with a given endpoint for the service. What an invocation handler is, this is how reflection in Java allows us to create proxies to intercept call of the methods from a set of interfaces. So imagine that when we create this proxy, we will dynamically generate a class implementing these interfaces. Is going to create an instance of that class, and each time we call a method of those interfaces, the worker will be invoked. it will have an invoke method that's going to be called. So what we return, we cast this instance to the type of the interface that is the contract of the service. And then each time when a method will be invoked with this proxy, this invocation handler will be invoked. So we will know what is the proxy that is handling the call, what method should be invoked with what arguments. And then we have a method to actually perform the call. So what we should do, imagine that when we create the worker, we just pass the endpoint as a URI, take the host and keep it separately, take the port from the URI, then the rest of the path will be the name of the service. And we just remove the starting slash in case there is one. Now, when invoking a method, we create a socket to connect to the remote partner, and we resolve the name of the host in case it's not just an IP. And we create the IP address we get the IP address of the host. And with the IP and the port, we create an endpoint and we connect to that endpoint. Now we create a request calling this service with the name of the method, with the arguments of the method, and with the previous session ID. We create a writer to output the call, and we just we use the transport to serialize the request. Now we flush the stream to send the request to the remote partner. We then create a reader on top of a stream reader, a buffered reader on top of a stream reader, on top of the input stream of the socket. Now we read a line that's going to be the response of the server, and we deserialize the response according to the RPC response type. In case we have a fault, we then throw an exception on the client side with the description of the message from the server. We store the session inside our worker, that is the value returned by the server. And in case we have a non-void result, we need to deserialize the result as the return type of the method that we call. So we then use the transport to take from the string that we kept as the result and deserialize it according to the result type. Now, when we deallocate this worker, we have a finalize method that eventually might be called, and we invoke the server to destroy the instance that has been created previously. So this is how the framework works. Now let me just show you how we can use it to implement applications. So I have a simple test in here. Sorry for that. When I define first a contract, so I imagine that I'm managing some nodes. I will have a method to return all the nodes, to find a node by the ID of the node, and it might return an optional of node, to add a node, and the node will contain only a title and a content, and in case it was able to add the node, it will return the node, otherwise the node will not be present. We like to change a node by the ID and reset the title and the content, and in the end removing the node. So a node is a simple model. As you can imagine, it has only 3 fields of type string: an ID, a title, and a content. Now when we create a node, we generate the ID as being a GUID, global unique identifier. We set the title and the content. The reason we have this private parameterless constructor is that it is used by the framework to deserialize a node. So even though it's a private one, the framework knows to make it accessible using reflection, but it has to be there. Now, it also has getters and setters for the values, and except for the ID, we are only getting the ID and not resetting it, and we have a toString to just be able to format the node. Now, having this, we also have some utility to start on a given host and port. And in case we like to intercept the call, I have here another port. So I will create a TCP trace. It's an utility. I will start this TCP trace just to intercept the channel. And we also have the name of the service. You can imagine that this settings class It's quite basic. It's loading the bundle based on the property file for the class, and it's getting the keys for the host, port, trace, and service. Now, what I have on the server side is quite easy. I have a service which is implementing the contract. So it will have a map of nodes. It will only store in memory nodes, and getting the values is quite easy. We take the values of the map and we convert it to an array. Finding a node, it's also straightforward. In case we have the node, we then return an optional with that node, otherwise we return an empty value. Adding a node, if we have the content and the title set, then we create a node, we put the node in the map, returning an optional of that object, otherwise we return empty. Changing a node, we find a node, and in case we have the node, we set the title and the content, returning an optional of that. Removing a node is quite easy. If we have an ID and we do have a node with that ID, we remove it and return true, otherwise we return false. So having this service, all we have to do is publishing an RPC server. So we create an RPC server. We then publish a service with this name, and we create only one instance of the service. So it's going to be a singleton publishing. All the clients will call methods of this instance. Now we start the server on a port and on a host. We then reading output managing commands, like exit is the only command that we implement. We create a scanner on top of the standard input, and we just read each line as a command. If the command is null, that means that the console has been closed, or we enter exit, we then stop it. And we make sure that we exit from this process. Now, on the client side, and this is the brilliant part, I mean the way we consume the service, we have a dummy client, which is a console application as well. So, I just created a command handler just to be able to register different callbacks for each command. So we handle the execution of the command with this interface. We have a map of commands, and we register what commands we know. We have a help command, and in case of a help command, we output all the commands by the name of the command that we can execute. So as you may see, we take the stream, we sort it by the name, and we iterate through each of the commands in the key set, and we just output the name of the command. Now, we are registering functional commands, like listening all the nodes. We receive a proxy, and we just call the method of the contract to get the nodes, and we then make it as a list and iterate, outputting each toString on each node. Now, finding a node, we first read the ID of the node, and then we take the line, and then we call the get node of the proxy on the server side to find the node. And if it's present, we output the toString of the node, otherwise we say we didn't find anything. Now, adding a node, it's the same. We read the title of the node. By the way, let's just delimit this correctly in here. We read the title of the node, we read the content, and we call the proxy to do on the server side to add a node. And if it was added, we just said that this node was added, otherwise it was not added. Changing a node, it's the same idea. So we read what was the ID, then what should be the next content, the new title, and then we call the proxy to change the node, and so on. Removing a node, we read the ID of the node, then call the proxy to remove the node, and that's all. Now, we are just initializing the proxy. So in case we are using the trace, we will connect to the trace on the loopback IP of the local host. Otherwise, should be the host that was set in the settings. The port is the same either we use the trace or we connect directly to the server. Now this is how we use our framework to create the proxy. So we just say, please give me an implementation of this contract that will call at this endpoint the methods. Now we just create a scanner on top of the system in console, and then we handle the commands. First we handle the help to display the available commands, and then we just wait for the user to enter exit. If the console has been closed or we typed exit, then we stop the process. Otherwise, we check if we have the entered command, and we take the command and handle it with the proxy and the scanner to output the result. Or in case we don't have the command, we just say, please type help for assistance. So now let's just see this running. First of all, I will start the server. So let's just go to the server and start this, run it as a Java application. So the server has been started. Now I will fire up another application, which will be our TCP trace utility. This is actually a server listening on the trace port and a client connecting to the remote partner, to the remote server. Now let's just fire up the client application, just run it as a Java application, and when we run it, we have a console. Now the console says what commands we can execute. Now let's just call a list command. We see nothing because we don't have objects on the server side, but this is how the protocol looks like. So we call the service called nodes with the method get nodes without any arguments or the session ID, and we got no result. Let's just go and try to add a node. So let's just call add. The title should be test1, yes, and the content should be content1. Yeah. So when we call this, we got a warning of the JSON, but forget about this. The idea is that this was the object created. We have the idea of the object, we have the content and the title. So if we look at the trace, we did another TCP call. This time we call the service called nodes, the method add nodes with the arguments that's an array test1 and content1. And this was the result. We are returning an optional, and the optional has a value with this content. So we have the ID, the title, and the content. Now when we having this created, this time when we like to list the values of the objects, we see we do have an object created here. So this is the third call that we did. We call the method getNodes, and we have the result, which is an array with these values. So that's about all. Thanks for watching.